Welcome to the Tomorrow's World Today podcast. We sit down with experts, world-changing innovators, creators, and makers to explore how they're taking action to make tomorrow's world a better place for technology, science, innovation, sustainability, the arts, and more. On this episode, host George Davison, who also hosts Tomorrow's World Today on the Science Channel, sits down with John Halverson, Director of Marketing at SMC. Founded in 1959, SMC Corporation skyrocketed over the years to become the global leader in pneumatic air-powered components like grippers for collaborative robots. We're uncovering how SMC is shaping the future, one compressed air-powered idea at a time.
It's great to have you here today. Well, I'm hoping that today we can help our audience take a look into the future a little bit as to where the jobs of the future are, and if we can explain a little bit about how you got to where you are in your career. Maybe we can shed some light on how things come to be.
Sounds good.
All right. Well, can you tell me a little bit about how SMC was actually founded?
Yeah, absolutely. SMC was started in 1959 in Japan, making the first product that they manufactured was sintered metal elements for industrial filters out of a garage, just a really small location. And over the next dozen years, SMC started manufacturing other components for industrial automation, including solenoid valves, pneumatic actuators, and air preparation equipment, so filters, regulators, lubricators to prepare the compressed air, which is pneumatics is the use of compressed air. Mm-hmm. And since that time, I guess in 1977, SMC started their U.S. subsidiary, SMC Corporation of America. I wasn't there at that time. That was a while ago.
I would hope not.
Right? And since then, we're now the world's largest supplier of pneumatic components for industrial automation, as well as we offer a lot of other products for industrial automation and process automation.
And why it works the way it does.
Right. So those are great questions. Our founder, Mr. Takada, was really looking for what customers needed. That's really been the driving principle of the company ever since it started, is listening to customers in the industrial automation space and finding out, do you have a problem? We can help you fix that. And we can try to create a unique solution that really helps customers to become more efficient and to lower their operating costs or lower their production costs.
So in a way, he was using his observational skills and his listening skills and going out to an audience and inquiring what are their needs so that he could figure out a way to maybe help fulfill those needs, and that created an opportunity. Is that fair?
That's a perfect assessment of it, yes. If there's a need, let's really understand that need from a lot of different angles, and then let's develop a product that's going to fit that need so that there's all the work that comes after that, but having that idea and a need from a customer is really the first step.
Wonderful. And then so he became somewhat of an expert in the world of pneumatics. And so why don't we delve into that a little bit?
I would guess that of all your listeners, 99% of them have a pneumatic device in their garage. It's called a bike pump. So a bike pump is essentially taking air and compressing it into the bike tire. Mm-hmm. So an industrial pneumatic system works very similarly, except it's working in opposite. We're using an industrial compressor to charge the tank or the tire, and then we're releasing the air in the other direction. For a bike pump, you're creating the force, you're pumping the tire. In an industrial application, the bike pump's moving on its own. It's using the compressed air as an energy source, and then it's perhaps holding a workpiece in place in a machine. It's moving a box off a conveyor belt, so the force is not applied by the human hand. The force is applied by the bike pump itself. So it's like a bike pump in reverse.
Wonderful. So in other words, like if I'm on the Amazon production line, there's 1 million packages coming down there a day. I wouldn't want to be the human being having to push the box off the assembly line 1 million times that day.
That's exactly right. Your arm would get tired.
Right. So a pneumatic arm, an air compressor, an air compression is starting to move that lever to
Right.
push the box off the line, isn't it?
That's right. Yeah, and it's without getting too deep into the math, it's force equals pressure times area. So if I have 80 pounds per square inch or 60 pounds per square inch of compressed air, and if I have a small piston, that's going to be a smaller force. If I have a big heavy box, I need a big piston. Big piston is more area.
Mm-hmm.
Force equals pressure times area. So a bigger area behind the piston means bigger force.
Wonderful. Hey, we just figured out that math is
math
important.
works. Yeah, I actually had a use for it. Turns out.
That's great stuff. Well, thanks for that. Hopefully that gets a picture going in our audience's mind as to how the world of pneumatics somewhat came about, and then how it's making an impact to make, let's say, work life better for human beings, right? So let's talk a little bit about your position at SMC, and can you walk me back to, let's say, can you remember back when you were in high school and what was going on, and take us through some of the good, and if you can tell us a little failure or two along the way. You know, like we usually fail our way forward in life.
Yeah, absolutely. So I went to high school in the Midwest, and I always knew I was on an engineering route. So I applied to several schools and was accepted to most of them, and went to school for mechanical engineering. And I was actually a mechanical engineer for 10 years, but found that wasn't really the right fit for me.
Interesting.
And went back to school and got an MBA, Master's of Business Administration. And then, interestingly, ended up right back at the same company that I started. So I left engineering, which the company was SMC. I left, did some other things, got an MBA, and said I'm going to go work in business, and ended up right back at the same company that I started with in more of a business role. So I worked in a product manager position, which is kind of in between our engineering group and our sales group. And really, if I could summarize my position, we in industrial marketing, we're looking for what do customers need and trying to understand how do we design products for the future. So that's probably the number one most important thing that my group and my department does.
Interesting. So when you're developing products for the future, of course, companies don't know what those things are yet. So part of the marketing need is to try to figure out a way to communicate the future in such a way that your new customer out there is going to understand what that new future could look like, right?
That's right, yeah. So sometimes it's, in order to get a new product, like a baseline of a product, we may have to create a prototype and show that prototype to customers and say, if you go with a blank piece of paper to 100 different manufacturing locations, you're going to get 100 different ideas. So we kind of have to narrow it down to a few things that are viable. And so a prototype product we might bring to a customer and say, well, do you like this one? And what do you like about it? What do you not like about it? And a lot of prototypes that we come up with don't ever even end up as products in the end, just because we had a better idea or we found that there wasn't a lot of interest in that product. The whole process of product development is there's a lot of starts and stops.
Yes.
And it's just really important to collect that data over time and really study it and really understand what customers want and need.
That's great information. So let's see here. So knowing what you know today, what advice would you give a person interested in entering your industry today?
That's a great question, George. And it's a different industry today than when I joined way back when. When I joined, you had your mechanical products, you had your electrical products, and where today there's a combination. Looking at high volume, looking at the factories that are being created today, there's really a need to understand both the mechanical aspect of a design and the electrical aspect. And oh, by the way, we can collect all this data now and put it on a cloud server. So there's an IT piece of it. There's an IT piece to the equation as well. So my advice would be learn a little bit of something about everything, use every day as a learning opportunity to learn a different skill, get a different skill in your toolbox. And a quote that I'd like to mention is, as a mechanical engineer, Isaac Newton is Newton's laws of motion. That's kind of like the core scientist who I built a lot of my knowledge around. And he had a saying. I don't think it was his saying. He's just the first famous guy that said it.
Okay.
He said something to the effect of, "If I could see further than other people, it's because I was standing on the shoulders of giants."
Mm-hmm.
So, and what he meant by that was, if you, or at least how I interpret that is if you can be mentored, if you can mentor someone, they're probably going to start at a higher level or a higher understanding of how the world works, and they're going to do better than you did. They're going to, and we see that through all the different technological innovations that are occurring today and the rapid pace of innovation.
That's a wonderful quote. Good, and thank you for that. That's another good story. All right, super. So next question would be, do you believe anyone can be successful?
Yes, I think anyone can be successful. I think confidence is really important.
Mm-hmm.
Treating others with respect is important. Being able to communicate is important. And it's not just being able to communicate, it's being able to communicate something of value, something that, or an idea or a concept. So absolutely, and I believe anyone can be successful. Maybe today people get perhaps pigeonholed into, well, you can't do this and you can't do this. And my advice to those people is, yeah, you can't. You can. You just have to find a way around that person who made you, explicitly told you couldn't do it. If you go through life stressed about, you can stress out about the little things, like, oh, did I lock my key? Did I leave my keys in my car? Did I forget to do this? Or you can worry about the big things, like, oh, am I going to be late for being on a podcast? So I've chosen to try to be worried about the bigger things.
Yes.
And then the little things just kind of go away.
That's great advice. Thank you.
Yeah.
How about mentors? Did you have any mentors when you were growing up? What giant's shoulders were you standing on, John?
Yeah, that's a great question. So of course, my parents, my grandparents, I had a lot of teachers who I know believed in me and who helped me to really understand abstract concepts or complex things. So as far as mentors, I don't have any one person in particular. It's probably a conglomerate of multiple, different people. There was the guy who taught me righty-tighty, lefty-loosey.
Right.
He was a mentor. You can learn from anybody. You just have to be able to communicate with them and, let them know, hey, I'm having some trouble here. In that case, that gentleman, he saw I was having trouble, and good for him. He could have just walked away.
Right.
He could have done nothing. Maybe I would have figured it out eventually. Maybe I would have thrown down the tools in disgust and quit and not gone into engineering.
Yes.
But I don't have any one particular mentor, but trying to just being kind and treating others with respect opens the pathways for that positive mentoring communication where you can learn from someone.
Right, and I think as we approach where we're getting a little older, I think it's a part of our responsibility to mentor those who are younger than us the way others mentored us. Right? I mean, I feel good always trying to help our youth to build their confidence, to try new things, experiment until they find a path that's their path. Right? And I like that a lot. So.
Absolutely, I would agree.
So I see something on the table here today. Do we want to touch on that a little bit? What's going on?
Yeah. So what I have here is it's a part. This is an end effector for a collaborative robot. So essentially, this is two fingers that can open and close to pick up an object, perhaps move it over here, and then drop an object. So this is designed to interface with a common manufacturer of collaborative robots, and it's using compressed air as the energy source, so it's a pneumatic gripper. And here I have all my communications through this cable, through this electrical cable. So I brought this because now this isn't everything that my company does, but I do think it's pretty inspiring because now I can say I make parts for robots, and that captures people's attention.
Right. And one day you'll be a grandpap, and hey, what's grandpap do? Well, he makes parts for robots. That's just cool.
Enough said. Then you just drop the mic after that. Right.
That's good stuff. Well, what a nice part. So, in other words, I'm on an assembly line, and maybe now I'm not just pushing a box off of the assembly line that has a million parts going by a day. Now we are picking a box up, maybe pulling it off and putting it on another assembly line. So that's what that robotic arm could do for us, right? Exactly.
Yeah. There's think about it, George. All the applications where a person can pick something up and place it now, once it becomes repetitive, we can do that now with a collaborative robot with robots, and it's we're going back to the first analogy with pushing a box off a conveyor belt. That's kind of brute force, where this has a little more finesse. This is more of a softer touch. There is still I don't know, this particular product wouldn't work well with like a donut. It's going to squish the donut. So you have to think about the force control. But there are products that can do that type of work as well. So where they have different ways to gently pick up an object without crushing it.
So isn't that interesting? We have the world of pneumatics, and then inside the world of pneumatics, there are many other little worlds, aren't there?
There are, yeah. There's so many, and there's so many different applications. A lot of times we'll have products that are kind of general purpose that can be used in a variety of applications. But say, for example, this component, this is designed specifically as an end effector for a specific brand of collaborative robots. So it's a very specialized part. But as the industry, as other manufacturers complete their product lines and build up their product lines, our products are continually changing to match up with those other innovations.
Understood. So in the early days, it was your founder as a single person, as an entrepreneur, and here we are all these years later. Are we talking about a couple hundred people who work with the company worldwide, or how large is the organization?
Yeah, so we went from, in 1959, just one person's idea, where today we have over 18,000 employees globally.
Isn't that wonderful?
Yeah, a lot of people.
A lot of people, a lot of jobs, a lot of improvement in people's lives from that one gentleman who decided to venture out there and become an entrepreneur and solve problems.
Right. That's right.
Isn't that wonderful? I had let's kind of move into the future if we could for a minute.
Sure.
So what do you think the next big innovation might be in your industry?
The next big innovation, well, there's a lot of right now there's a lot of cables, and one of the products that we had highlighted recently was our wireless communications system. So a lot of times, I really see wireless and products that can communicate with different industrial Ethernet networks and other communication protocols. So there's a lot of, I'll call it digitalization.
Yes.
So combining a mechanical design with an electrical control system, but making sure that it's done on a safe protocol with all the machine safety in place. So really, I guess I'll summarize. It's really three things. It's sustainability. How do we make products that consume the least amount of energy that for a given output? It's safety. How do we design products that meet all necessary safety requirements so people are safe during the manufacturing process, and the products that manufacturers are making are safe? And digitalization. How do I send feedback through for this product that we're looking at here? How do I send feedback back through this cable to a programmable logic controller So I have a digital record of how many times this gripper, how many times it actuated.
Understood.
And we can use that data for predictive analytics.
Mm-hmm.
So as an example, if I see a pneumatic actuator and its cycle time used to be 3 seconds and now it's 4 seconds, maybe it's time to change that. Maybe I've got a broken seal, maybe I've got a leak in the system. So trying to use data, IT analytics, to improve the operation of machines.
That's very interesting. So you can predict when, let's say, a seal is going to go bad and you're going to lose 25% of your efficiency on a production line.
That's right.
And then that leads to additional problems in that system, right? So seeing that you are always running at optimum performance would be the goal, right?
Yeah, it's almost like, in a way, it's almost like you'd mentioned in the beginning about our bodies there's similarities between our bodies. So if my blood pressure is going up, that's a signal I need to do something. I need to exercise more. I need to do something. In a pneumatic system, in a machine, we see those same signals. We just have to be able to measure them and pay attention to them.
Yes.
So if I'm not taking my blood pressure reading when I go to the doctor and I have blood pressure problems, well, it's because I wasn't measuring it. Where in the future of pneumatics, looking at trying to get more of that data, whether it's blood pressure, whether it's pressure, the flow, the cycle time, the position of a part. And keep in mind, we have a lot of machines that are produced. We have a lot of data from different machines. So I can have 10 different machines, and I notice that all 9 of them are operating exactly the same within a set of parameters. But machine number 10 is doing something a little wonky. It's doing something different than all the rest. So I can study that data over time and predict in advance, whenever we see it start doing that thing that it does, it's time to change this part on the machine.
So you go down there with your screwdriver and lefty loosey, and you go through the process of changing that out.
That's right. You remember back to that guy that told you that righty tighty lefty loosey. That's right.
Oh, isn't that fun? You're having sounds like a great career. It sounds like you're happy with your work and you're progressing very nicely. Well, I'd like to thank you for being on this episode. And folks, that is John Halverson. He is the Director of Marketing, SMC Corporation. Thank you, John.
Thanks for having me.
Bye now, everybody. Have a great day.
Thank you for listening to this episode of Tomorrow's World Today podcast. Join us next time as we continue to explore the worlds of inspiration, creation, innovation, and production. Discover more at tomorrowsworldtoday.com, connect with us on social media at TWT Explore, and find us wherever podcasts are available.